Good morning, dear students. Welcome to this session on pre-stressed concrete. Last session, we have talked about the calculation of resultant stresses in a pre-stressed concrete member. And we have seen the examples also, two such examples. So you have to practice them a bit exhaustively, like taking some other examples from the prescribed textbook by N. Krishnaraju. You have to practice all those examples given in the textbook, and also any other source you have to practice such problems, you can take it up. Okay. Now moving on to the next content, that is finding resultant stresses by other concepts like pressure line concept or internal resisting couple method, or simply called C-line method. Okay, so famously known as pressure line concept. The other way you can call it as internal resisting couple method, or C-line method, nothing but compression line, C-line in the sense compression line method. Okay, right. Let us see what it is actually. What is a pressure line? Line along which the resultant compressive force acts is called line of thrust or pressure line. So, in a concrete member, after pre-stressing and after loads, transverse loads are applied, in the final stage, like if it is in the service, the concrete member, you take each cross section and work out for resultant stresses, and you will find the resultant stress across the cross section in a different manner at each section. So some locations there will be fully compressive stress from top to bottom of the cross section. Some cross sections will be some portion till some portion it will be compression, then tension, likewise. So it is a mix of all. So if you can trace the resultant of that compression area, the CG of that compression area from each cross section and draw a line, that is what is called pressure line. Okay, let us see how we draw it in further sessions. Line joining centers of compression of all cross sections of the member is called line of thrust or pressure line. This is what the other way of telling what is pressure line, right? So a line along which resultant compressive force acts is called pressure line, or the line joining center of compression, like CG of that compression areas, okay, of all cross sections of the member is called line of thrust. Okay, uh, just for example, I'll just show you. So for example, this end cross section you take and draw something like this. So this is positive, okay, and take the center cross section and draw something like this, and take this end section and draw something like this. Okay, now you find CG of this compression diagram, compressive stress diagram. Find CG of this one. Say for example, this is CG of this one. This is CG of this one. This is CG of this one. So just join all those points like this. So this is what you call pressure line. Just as an example, a rude example I say. What exactly we will get, we will just follow in the next session. Okay. Right. The concept of pressure line is very useful in understanding load carrying mechanism of a pre-stressed concrete section. This is the use of this pressure line concept. Okay. Right. So what is a pressure line? We have seen, and what it is useful for. Okay. So a pressure line is nothing but joining the center of compression of all cross sections, uh, a line joining of all centers of compression is nothing but the pressure line. Okay, right. So now you take one example, a simply supported beam. Okay, this is just a simply supported beam, pre-stressed by a cable at an eccentricity of h by 6. This is h. Okay, the height of the beam. Say for example, this is h. Right. So it is pre-stressed by a force of P, capital P, pre-stressing force with an eccentricity of h by 6. Okay, right. Now let us see how you draw pressure line for this. This is the cable location of the cable line we say. Okay. Now how you get this pressure line? Pressure line. Okay. This is a pressure line. Right. So uh, imagine that the section is pre-stressed by a force of P at an eccentricity h by 6. Okay. Right. Now let us take the support section where simply supported beam means what? Bending moment is 0. Okay. Now, because of pre-stress, what are the stresses at the end section? It is P by A. Right. If it is a top, okay, top section, this point, support section at top, you see top tension. Okay, so minus P E by Z. Okay, that shall be equal to 0. This is a total no uh, stress value at top. Okay, right. So P by A minus PE by Z. Right. So what is no the value of E here? H by 6. Substitute for H by 6. E is equal to H by 6 you substitute. Okay. And Z is equal to BH square by 6 you substitute. A is B into H. Substitute that value. Okay. B into H. Okay. Right. So let us see that value of stress at support. So P common 1 by BH minus P common is just gone out, H by 6 divided by B H square by 6. So 6 to the numerator. 6 has gone. H gone. 1 by BH minus 1 by BH. So what is the stress value at top? 0. That is what you can see it here. Stress at top is 0. Okay. What is stress at bottom? Just plus symbol. Bottom stress, this point. At this point, what is the stress value? P by A plus PE by Z. So what happens? You will have to replace this minus by plus. Okay. So what happens? So P is common. P into 1 by BH plus 1 by BH. Okay. So it is like 2 divided by BH. Is something like the stress value. That this value of compression is this much. 0 at the top, and it varies linearly across the section. And strains are proportional from top to bottom. That's why we will have a linear relation from top to bottom. So support cross section we have taken, and we have calculated stress at top. We have got 0. We have calculated stress at bottom, that we have got 2 times P by BH, that is the value, and everything is compression. There is no tensile stress at all. So now you find the CG of this triangle. Okay, where will be CG of the triangle? H by 3 from base. I mean this is H by 3 CG. Okay, this is H by 3. Okay. What about this one? Half of the H, that is H by 2. Okay. What is eccentricity? H by 2 minus H by 3. Okay. That is H by 6. So resultant compression is matching with the cable line here. Okay. That means cable line is here, and also resultant compression is also at the same point. So support sections, you can see, for a simply supported beam of height h having eccentricity h by 6, the pressure line starts at the cable line itself. Then what about the center section? You take the midpoint, middle section. Okay, take the middle section, and again draw the pressure line. Find the stresses. Okay, you will have this nature of stresses. So top, bottom stress is 0, and top it is same way. Okay, so what you get is again the CG of compression from top, it is H by 3. Again, if you work out, works out to be H by 2 minus H by 3 will be H by 6. So this is the location of resultant compression, H by 6. And even you take quarter section, quarter span. Okay, so what will be the bending stress along with the the loads and all. Okay, pre-stress and loads, if you combine everything, the quarter section, the resultant stress is a trapezoidal diagram. Okay, and this is the stress diagram at quarter span section. And CG, it works out to be H by 12 from center. So H by 12, half of this value. So these points you can locate. So here you are locating at H by 6 below CG of concrete. Here you are locating H by 12 above CG line, and H by 6 above CG line at center. Because of symmetry, the same points will be located, other half also. Just join those points by a parabola. Okay. Right. Reason behind drawing it as parabola, because the bending moment in a simply supported beam varies parabolically. So you are using the bending moment to locate this pressure line. That's why the compression line also shall follow bending moment nature. Okay, right? So maximum bending moment at center. So hence you have to locate the maximum eccentricity at center. Okay, so this is how we locate pressure line in a member. Okay, right. So just to draw the stress diagram, resultant stress diagram, draw resultant stress diagram, find CG of compression area. CG of compression area, if you find, just join those CG of compression lines. Okay, so here there is a point here, and here it is CG of this point. This is the CG, and this is the CG. Okay, so this is for half of the cross section. Okay, and the other half also same way, symmetry. So that's why all these 3 points are being dropped to other half also. So now you can complete this pressure line. Okay, so this is a cable line, and because of that pre-stress, the compressive stresses will act like this. Okay, that is how you draw pressure line. Okay, so to draw pressure line, it is very simple. Uh, take the salient locations for plotting the pressure line, and at that salient location, for example, support section and 1/4 of the span and middle of the span, then work out for resultant stress diagrams. Once you draw resultant stress diagrams, then you work out for the location of CG of that compression area. Join all those points, you will get the pressure. Okay, right. There is some information when compared to the pre-stressed concrete member and RCC member, how the pressure line is going to behave. Change in the external moments in the elastic range of pre-stressed concrete beam results in shift of pressure line rather than an increase in resultant force in the beam. Okay, so if you have a beam, okay, so if you just have a load on this, imposed load, some imposed load, okay, W, right. So what happens if W is increased? Okay, in case of pre-stressed concrete beam, the pressure line will be shifted when you increase the load or when you change the load. Pressure line will shift. Okay, that is a point what is told. If moments are small, shift is also small. Okay, the parabolic line that we have drawn, if you increase the load, that parabolic line will shift upwards. You reduce the load, parabolic line shift downwards. Okay, the shift will be there in the pressure line. Okay, whereas in case of RCC members, this is regarding pre-stressed concrete members. So in case of PSC, change in the load will cause shift in the pressure line. Whereas in RCC, increase in moments cause increase in tensile force and compressive force, and there won't be any change in the lever arm. Lever arm is fixed. Okay, what is a lever arm? Lever arm means the distance between the tensile force and the compressive force developed in the cross section. Okay, so lever arm is fixed in case of RCC because of what? See, this is a RCC beam. Okay, where you have steel bars, RCC, HOSD bars kept here. So this is a location where tensile force develops, and this somewhere uh, in concrete, this is a location where compressive force acts. Okay, right? So this lever arm, whatever is available, this is fixed, small a. What happens when you increase the load? Value of C and T will increase. A is fixed. Whereas now in case of pre-stressed concrete beam, what is happening? So this is a duct where the cable is available. Okay, and this is the CG of cross section. Okay, right. So what is happening? This is the force in the cable, the pre-stress high tensile steel. Say if the load is some value, you are going to have compression, center of compression here. So this is a C line. Okay, the point where C is acting. This is a lever arm. What is happening when load is increased? The C point CG of that compression is shifting. That means location of C is changing, not the value. So A is changing, lever arm is changing. Okay, not the C value and T value. These are constants. A is changing, lever arm is changing because the location of C line is shifting. Whereas here, in case of RCC, the A is fixed, lever arm is fixed because the CG of compression is fixed. Only the tensile force and compressive force will change. Forces will increase. Okay, that is what is the difference between this one. Okay, so this is how the pre-stressed concrete member takes the loads. So if you increase the load, the tensile force and compressive force are same. Only the lever arm is changing. Okay, this is what is the load carrying mechanism in pre-stress when compared to RCs. Okay, right? That will be explained, with the diagrams and all, and we will see how to find stresses with this concept. We'll clearly discuss in the next session. Okay. So this session, I have introduced you the another concept of finding resultant stresses. The first concept is directly finding resultant stresses by stresses due to pre-stress and dead load and live load. Now it is by using the C line, we can find the resultant stresses again. So what is a C line or pressure line, and how it is useful, and how you draw a C line for a cross section given, and how the load carrying mechanism difference between the RCC and pre-stress concrete. We'll see, even we'll continue this discussion even further also with the other the diagrams and all. Okay, right. See you in next session.